Okay, so linear inequalities are going to be two parts. So you've got the boundary and you have the region. So the boundary is going to be your straight line. So the stuff that you learned how to graph in grade 10. Ooh, that's supposed to say line. It doesn't look like it says line, but it's supposed to say line. So the boundary is that straight line. And the region is the part that we're going to shade. So we're going to do a little bit of coloring. We're going to be doing a little bit of coloring in this unit. Okay, so you need to graph your boundary first, or the equation of the line, and then shade the region of the graph that satisfies the inequality. So remember that inequalities are used when there's many correct answers, not just one. Like an equal sign is for like one correct answer. X equals 2. But if I said X is greater than 2, I think that we all probably could come up with a number that's greater than 2. And all of ours be unique. Does that make sense? So we're going to use inequalities when there's many solutions. So we use an inequality when we have many solutions. Okay, so when graphing a boundary, here's the thing. If it uses the greater or the less than or equal to or the greater than or equal to, the key here being the equal to sign. That's the key on these ones. It's the equal to sign. You use a solid line because any point on the line is part of the solution. Now, if I don't have that, if I just have a greater than or less than sign, we're going to use a dash line because any points on the line are not included. Does that make sense to everybody? Like, let's talk about X. If I say X is greater than 2, can you guys all give me a number greater than 2? Give me a number greater than 2. 4, 3, give me one more. 5. Okay, you guys are wild and crazy. Would a million work here? Yes. So, okay, so right there, we have that. Is 2 a correct answer for this one? No, because X has to be greater than 2. But if I wrote X is greater than or equal to 2, all these answers still work, but what could I add to that one? Now 2 is included. So if you have the equal to sign, it's a solid line because it means that 2 is included. If you don't include 2, it's a dash line because you're saying, hey, 2 is my boundary, but it doesn't include 2. So if it doesn't have that equal to sign, you're going to have a dash line. I would highly encourage you guys to use pencil in this unit. So when you draw it in straight because you've forgotten, you can go back and just erase it and make it dashed. So that's my wild world of advice to you guys. Okay. Then we're going to do the shaded area, and we're going to pick the test point, and it's going to work, or it's not going to work. All right, example number 1. We have to graph this inequality, and then it's asking, is 1, 3 part of the solution? Okay, so first thing we're going to do is we're going to graph our boundary. You guys all know how to do this. If this makes more sense to you, graph that. Okay? Now that's not your answer because it does have the equal to sign, but your boundary is going to be this. How would you approach this if you were in a linear situation? How would you do this? We did this in we did it in exam review, I think, just the other day. Maybe I'm mistaking it. Oh, geez. How would you deal with that? Guys, if you don't know how to deal with it, then you're going to run into trouble. Hello? Yep. Yeah, there's me. Yeah. Okay. I will tell her. Okay, bye-bye. There's me. I did. Your dad wants you to call him. So you can either go down and use the main office phone, or you can go out in the hallway and use your own phone. Okay, anybody? Any suggestions on how we would do this? Who? What? You could totally do a table of values. They'll never lead you wrong. I think for me, I'm going to rearrange this so it equals y. That's what I'm going to do because it makes more sense to me. So y is positive on this side, so I'm going to have 2y equals negative 4x plus 10. I want 2 by itself. So this is the trouble. If this was negative, you're going to have to flip that inequality, and I'm not using the inequality, so that's a little scary. I got to remember all that stuff. So this is going to be y equals a negative 2x plus 5. Ooh, sorry. Do you guys know how to graph that without using a table of values? The intercept slope method, super easy. But again, a table of values will get you to the exact same points I'm about to do. So let's go up by ones. 1, 2, 3, 4. 1, 2. A table of values will help you feel more confident in what your increments should be on the graph. So if that's helpful to you, I would encourage you to do that. Okay, so now I'm going to graph this. So I have a y-intercept of 5, so way up at the top there. And then my slope is negative 2, but it's negative 2 over 1. So that means I'm going to go, because it's rise over run, so it's y values first and then x values. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Okay, so I have my handy dandy ruler, and hopefully it looks pretty straight. Now, before I draw my boundary on, is this a solid line or a dashed line? Solid, because it has the equal to sign there. So that's the thing that always screws me up, is I draw that solid line in, and then it doesn't have the equal to sign, and then I'm like, I gotta either use whiteout or something. Okay, so you've drawn the boundaries. So that's grade 10. What makes this grade 11 is we're adding the inequality, so we're adding the shaded region to it. So now what we do is we pick a test point. So when you pick your test point, you want to pick one that's clearly on the left-hand side of the line or the right-hand side of the line. And then I want you to pick a really easy one, mathematically speaking. So what point do you think I'm going to encourage you to pick? How about something even easier than that? 0, 0, right? Is that not on this side of the line? Right? So all I'm asking you to do is to pick a test point either on this side or on that side. And so my test point I'm going to pick is right here. I'm going to pick the test point 0, 0. And then what I'm going to do is I'm going to substitute that into the original equation, or the original inequality. All right. So I'm going to have 4 times 0 plus 2 times 0 is greater than or equal to 10. So 0 is greater than or equal to 10. Is that a true statement? No. So that would be false. So if it's false on this side, what do you think it is on the other side? If it's false on the left-hand side, what is it on the right-hand side? If it's not false, it is true. So, I mean, you could double check and you can pick a point on the right-hand side if you want to, but you shade where it's true. All right, so we decided that 0, 0 was false. I'm just going to pick a point just so we can prove it. So I'm going to pick 3, 3. So my next test point is 3, 3. And so I'm going to have 4 times 3 plus 2 times 3 is greater than or equal to 10. So 12 plus 6 is greater than or equal to 10. 18 is greater than or equal to 10. Is that a true statement? Yeah, that one's true. That's a true statement. So what we're going to do is we're going to shade on the side of the line that is true. So I'm getting my handy dandy pencil out, and I'm going to shade this side of the line. Now I will tell you, if you get a test point that's false, and you trust your math, and you've done everything correctly, if you trust your math, if you stopped there, that would be fine, because you know that this point doesn't work. So if this side's false, then this side must be true. You can go with that if you trust your math. If you're not positive, if you don't trust your math, like there's fractions or something in it, pick a test point on the opposite side of the line and try that again. So this is an inequality, boundary in the pink and the shaded region. If you don't give me both, then you haven't answered the inequality. Does that make sense to everybody? Okay, so now the question is 1, 3 part of the solution? So point 1, 3 is right here. It's on the actual line. So is 1, 3 part of the solution? Yes, it's on the line and our line is solid. So yes, it is. Now, if it was a dash line, we would then say, no, it's not, because we know that the boundary is not included in the solution. So pretty straightforward today. So it's going to be graphing lines, picking a point, and coloring on the side that's true. Now, notice how there's a lot of questions about shading. I only go to where my line goes. You don't have to get too crazy with it. Notice how that went over the line, so that would be incorrect. So I got to make sure that that's erased. So just make sure that your shading is appropriate, and it should come down and it should touch the line. Okay, so you actually have to color within the lines. I'm sorry. I'm requiring your art to be very specific. All right, okay. Easy peasy. All right, let's do this one. What do you guys want to do with this one? Do you want to do table of values for this one, just to show an example of that, or do you want to do slope-intercept? You want to see a table of values? Okay. So if I'm going to do a table of values for this one, I'm going to pick some values that are positive, some that are negative, and I'm going to throw a 0 in there. So I'm going to pick -2, -1, 0, 1, 2. So I have to substitute each value in for where I see x. So I'm just going to pop to a scrap piece of paper here. So I'm going to have 10 times -2 minus 5y. And again, that inequality is greater than 0. But really for this one, you just need to put in equal to 0 because you're getting that boundary line. You're getting what that boundary is. So I've got a -20 minus 5y equals 0. So y is equal to -4. Okay, so my table of values, this is -4. So 10 times -1 minus 5y equals 0. So -10 minus 5y equals 0. So it's going to be a positive 10 when I bring it to the other side, if you need to see that math. So y is going to be a -2. If I throw 0 in there, 10 times 0 minus 5y equals 0. So I'm going to have -5y equals 0. So y is equal to 0. Oh, you guys can't see that. Andrea, you okay? No? How come? Is that... So my guess is it's probably not super important to you. It's scary? I promise you, we'll protect you. Okay, we'll protect you. What? Oh dear, I wasn't planning on doing that, but sure, I guess. Poor Fumi, did you see how fast that changed? Like, friends off, you're the first one to go. Okay. So that's all scrap paper. I really don't need to see this, ladies and gentlemen. This is all on scrap paper. What I do need to see, though, is your table of values. Okay? Okay, so we're going to go up by ones again. It was a questionable 2. And again, you guys don't have to rate all the increments. You have to rate some of them, but like I said, I'm not strong at that. Okay, so I'm going to plot my points. So I've got -2, -4, -1, -2, 0, 0, 1, 2, and 2, 4. Okay, so before I join the dots, I got to ask myself, is this line dashed or is it solid? This time it's dashed. So if you can remember to do that, you'll be like way better than I am. What did I forget on the last one? What didn't I do? I didn't label 2 points. Always, on every graph. Always and forever. Okay, there, I got 2 points labeled. All right, so I've done my boundary. The next part is the shaded region. So normally my favorite test point is 0, 0, but I can't pick 0 this time because why? Why can't I pick 0, 0? Because it's part of the line. I have to pick a test point that's significantly left or significantly right of the line. Any suggestions? 0 and 2. All right, I like it. I like that we included a 0. So the test point I'm going to pick is 0 and 2. And it is to the left of the line. So I'm going to go ahead and substitute that into the original equation. And this I want to include to make sure that it's an inequality this time, not an equal sign. Like I want to go back to the original inequality. So I'm going to have -10 is greater than 0. Is that a true statement? No. So that's false. So if it's false on the left-hand side of the line, that means that it is true on the right-hand side of the line. Now the question is, do you trust my math? No. Parker's like, yeah, I trust your math. Fumi, you don't trust my math. Some days I wouldn't trust it either. So what's a point on the right-hand side that we can check? Who, what? 0, and I like 0 and -2. We're reflecting it, but it's on the opposite side of the line, right? Doesn't matter which point you pick, but it just has to be on the right-hand side of the line. So test point is 0, -2, and we have 10 times 0 minus 5 times -2 is greater than 0. So positive 10 is greater than 0. Is that a true statement? Yeah. So that one is true. So we're going to shade on that side of the line. Go back and erase any things outside the line. And again, like as long as I can see what side is shaded and you've done a pretty good job, I'm not going to be too super particular. Like if this isn't shaded here, I got that it's this side of the line. Like I understand that. All right, now we're going to go all the way back to grade 10 and we're going to create equations of lines. But this time we're not going to create equations, we're going to create inequalities. So I don't know if yours photocopied. Well, yours would have photocopied the same way I did. You should notice that the bottom side of graph 1 is shaded. The top side of graph 3 is shaded. The bottom side of graph 2 is shaded. And the top side of graph 4 is shaded. Like you can kind of see it, but yeah. That one? All right, we good? We can continue on? Okay, so we're going to create some inequalities. We might have to hop to a scrap piece of paper if there's not enough room. So first and foremost, so I'm going to do graph 1. Graph 1. All right. So we need to figure out the slope and we need to figure out the y-intercept. As I throw my pen around. So what's the y-intercept? So where does this inequality cross the y-axis? -4. Okay. And now what's the slope? So remember that the slope is the change in y over the change in x. Okay, so let's talk about it. So we've got to talk about the y. So if I start here and I go to my next point, and I'm going to pick a point that's obvious, right? It doesn't have to necessarily be the next one in the sequence, but I'm going to pick a point that's obvious. So this one crosses at 4, 0. So let's talk about it. Please pay attention to your increments on these graphs, because that'll mess you up too. You'll think it goes up by 1, but if you don't pay attention to the numbers. So if I started at 4, so this one is 0 and 4, and this one is 4 and 0. So if you guys remember the slope formula, I'm going to take my y value, 4, and I'm going to minus the second y value from it, which is 0. I'm going to take my first x value, which is 0, and I'm going to minus the second x value from it. So I'm left with 4 over, sorry, this is a -4. No, I messed something up. What did I mess up here? That's a +4. That's a -4. Whew. So -4 over a -4. What's the slope? 1. Okay? You can also look at it. You don't have to show me the math that goes with it. That's fine. Okay, so the format for equations is y, and then we don't know what the inequality is yet, so I'm going to use a fluffy cloud. Slope times x, y-intercept. So it's either plus or minus the y-intercept. Ours is at -4, so it's going to be subtract 4. So you guys should have done this in grade 10. If it doesn't feel that comfortable, hopefully you'll practice it a few times and it'll be better. So we need to figure out that inequality. Okay, so we only know we only shade where it's true, right? So when you're creating these, you must pick a point where it's true. So must pick point where it is true. All right, so I'm going to pick a nice easy point in the true section. So it's got to be fully in the true section. So give me a point that's fully in the true section. Anybody? What's a coordinate pair in the shaded region? 6 and 0. Nice and easy point. Would you guys all agree that that point there is in the shaded region? Okay, so now we're going to use our point, 6 and 0, and we're going to substitute in where we see x and y. So 0, fluffy cloud, 1 times 6 minus 4. So 0, fluffy cloud, is 4. All right, so let's make a statement about that. Is 0 greater than 4 or is it less than 4? Oh, sorry, it should be -4. I did the math in my head. So is 0 greater than 2 or is it less than 2? 0 is less than 2. Everybody agree with me? Now, do I put equals in there? Brendan's shaking his head no. How come? You're correct, but how come? Because what's this line? It's dashed, right? So it's a dashed line, so I know I don't have an equal sign. So this is going to be 0 is less than 2. So our inequality would be y is less than x minus 4. That's the inequality for graph 1. I'm definitely going to need scrap paper to do the rest of it. Okay. Fumi, your row is going to do graph 2. Dersimi, your row is going to do graph 3. Okay, you're going to create the inequality for graph 3. The rest of you, the 4 of you left, are going to do graph 4. No. You have so much luggage, it would take you 7 years to move from spot to spot. No, I need you in that row. We need 3 people, a minimum of 3. Okay, so everybody's going to do their inequalities. What do you think? If Fumi's row is 2, what do you think your row is? Hopefully 3. Okay. Okay, so everybody should be building their inequality right now. You guys good? So if we haven't done a cheat sheet for chapter 1 yet, tonight might be a really good time to build it to help you study for the test for tomorrow. Yeah. Sure. The teachers voted about exams? Yep. I was kind of the mediator for it, so I really didn't have I didn't put my opinion in either way. But I think there's value in doing exams. I think for you guys going off, most of you will go off to post-secondary. Either you're not going off to post-secondary, like if you're going to do trades or you're going to do training on the job, there's always exams with stuff, right? And they're usually pretty high stakes. So it's good to get a little bit of practice. Okay, let's look at what we got here. All right, this is what I got for my 3 equations. Oh my God. Graph 2, is that what you guys got? Yeah? Okay, good job. Graph 3? Yes? Dersimi's not, are you convinced or not convinced? Okay, Nandi, what about you at the back? That's what you got? Okay, graph number 4. What about you, 4? Yes? Keegan? Kinda, sorta? Yeah? Okay, all right. Okay, if you're still struggling with how to create an equation of a linear, let me know and we can go over that a little bit more in detail. I know some of you are solid on it and then others don't feel as comfortable. All right. So here we go with a word problem, because you know, nothing says fun like a word problem. Find all possible combinations of tile and stone that can be used to create a mosaic. Do you guys know what a mosaic is? Yes. It's like pieces of many things to create like one art piece. The tile costs $2.50 per square foot, and the stone costs $6 a kilogram. The budget for this project is $150. Create an inequality to represent the situation and solve the problem. All right, here we go. You ready? Okay, how much money do I have to spend? $150. Can I spend exactly 150? Can I spend 151? No, I can only spend 150, right? So we know 150 is our maximum. So everything on this side of the equation has to be less than or equal to 150. Does that make sense? I can't spend 151. This side has to be either equal to 150 or it has to be less than 150. All right. Okay, so creating a linear equation from grade 10, we're digging deep. What do I have? I've got 2 different variables. What am I dealing with? Tile, and I'm dealing with stone, right? So I have 2 different variables, x and y, s and t, whatever you want to call it. So I'm going to define my variables first. So let t equal square footage of tile, excuse me, and let s equal the kilograms of stone. All right. So if I have 10 kilograms of stone, how much is that going to cost me, ladies and gentlemen? $60, right? Because each kilogram is $6. Everybody get that? So what did I do between the 6 and the 10 to give me 60? I multiplied them. So really on this side, I'm taking the cost of the stone times by how much stone I have, and I'm taking the cost of the tile by how much tile I have. And it doesn't matter that like tiles measured in square foot, stones measured in kilogram, it doesn't matter. And what am I going to do to these things? Don't I have to add up I have to add those together to get my total. So ladies and gentlemen, you have just created your inequality. There's no trick to it, but it does take some thinking about it. Like it's not like step 1, always do this. You kind of have to look at what the situation is and adjust based on that. So we created an inequality. Now it says solve the problem. Well, what does that mean, Scallion? What the heck? I don't know what that means. A graph is going to best represent this. So I'm going to do a graph. Can I have negative square footage of tile? Can I have negative kilograms? No. I'm going to put my stone here and my tile here. Could I have done it the other way? Totally. There was no rhyme or reason why I picked that. But what I do know is that that can't happen in the real world because I can't have negative kilograms and I can't have negative square feet. Okay, so I'm going to graph this by doing intercepts. So if I'm looking for the t-intercept, what's the value of s? If I'm looking for the t-intercept, what's the value of s when it's on the t-axis? 0. All right, so we have 150, and we're going to switch it to an equal sign. 6 times 0 plus 250t. And so, oh geez, sorry guys, you can't see that. So I'm going to have 150 equals 2.5, I said 250, but it's 2.5t. So here, 150 divided by 2.5. So we know that the t-intercept is at 0 and 60. You guys would agree with me? So that means if I have no stone, how much tile can I buy? I can buy 60 square feet of tile if I have 0 stone. Make sense, everybody? Yes? There's a question on your test like this, FYI. So now if I want to find my s-intercept, what's my value of t? 0. So 150 equals 6 times s plus 250 times 0. So I'm going to have 150 equals 6s. And that's going to be 25 equals, I was going to write t, but that's not my variable. So that means here, this is going to be 25 and 0. So what does this point represent? How much tile do I have? Nothing. I have no tile. So this means I can have 25 kilograms of stone if I just was doing the mosaic with stone. Well, I'm going to connect these 2 points. And so is it dashed or is it solid? Solid. Good job, everybody. Okay. Oh, I guess this shouldn't be shaded because we're doing an inequality. We just know it can't exist, right? All right, so now what I have to do? What do I have to do? I have to figure out if my points are under the line or over the line. So what am I going to do? What did we do in the other ones to figure out where we shade? Pick a test point, right? So what test point do you want to pick? 0, 0, okay. Well, that's going to be nice and easy. 150 is greater than 0 plus 0. Is that a true statement? Yes. So notice that my shading doesn't go outside of these lines. I'm actually shading like a triangle area because I can't shade into the negative because the negative doesn't exist. We just talked about that. So the solution for this is anywhere in the shaded region. So I could have all tile, I could have 60 square feet of tile, or I could have 25 kilograms of stone and no tile, and then anywhere in between that, anything less than that. Like I could have 1 and 1. I only need 1 kilogram of stone and I only need 1 square foot of tile. I'm going to spend a lot less than 150, but that's a valid solution, right? So my solution is the shaded region and including the line. Okay, so that's it. That's all.